All right, we're back today with hypotheses test for two proportions. So yesterday we looked at a video on intervals, and like I said, I'm going to keep this one a little bit shorter, actually a lot shorter today. I'm not going to get all the way through this just so you guys can go work on the reading quiz during class instead. But I do want to introduce these, and then when I come back on Monday and we get back together, we'll finish these up and look at them. So obviously we're going to look at two different parameters again. Right? We've got two different samples, but this time instead of trying to narrow down the true parameter using an interval, we want to see if the difference between these parameters actually is statistically significant and didn't just happen on accident, okay? So our null hypothesis is pretty much going to always be, when we think about the sort of general form here, P1 minus, or P sub 1 minus P sub 2 is equal to the hypothesized value. Typically, we're pretty much going to restrict ourselves to a situation in which the hypothesized value or difference is 0. Because if you think about the null is based around no difference, and no difference would be 0. There's 0 difference between the two things, right? So we'll either say one of two things. Either we'll say, P1 minus P sub 1 minus P sub 2 equals 0, or maybe we just add that P sub 2 over to the other side and just go ahead and say P sub 1 equals P sub 2. I tend to, go a little bit more towards this one here. I just like to see that 0 in the hypotheses. Same thing with the alternative. Obviously, we can have a greater than, we can have a less than problem, or we can have a not equal to problem. And again, you can rearrange all three of these. So in other words, you could do like P1 is greater than P2 by adding P2 to the other side. In this case, P1 is less than P2. And in this case, P1 is not equal to P2, right? So you have those three options, and then the alternative below it. So let's just kind of work on stating a parameter and then a hypothesis here. So are teenagers going deaf? Well, in a study of 3,000 randomly chosen teenagers between 1988 and 1994, 15% showed some hearing loss. In a similar study of only 1,800 teenagers between 2005 and 2006, 19%. So we can see it went up 4.5%, but again, we're not sure if that's significant or just, by chance due to sampling variability. So we want to find if there's convincing evidence. So what we're going to do here is we're going to define parameters and set up some hypotheses and nothing more than that. So I told you you can kind of define a single parameter, but since we're probably going to use like P sub 1 and P sub 2, or I don't know, maybe it's kind of hard to use numbers in this one because you can't do like P sub 88 to 94 and P sub 05 to 06. I mean, I guess you could, but it would just be a lot to write over and over and over again. So since that's the case, I'm just going to use simply, P sub 1 and also P sub 2. But let me define this one first so I leave myself enough room, and then we'll define P sub 2. So this is the true proportion. All right, so the true proportion of teenagers between 1988 and 1994 who show hearing loss. And then down here, P sub 2, we'll say almost the same thing. The true proportion, whoops, I missed let me back that up here. True proportion of teenagers between, 2005 and 2006, who show hearing loss. All right, now obviously we're going to be concerned about the difference between these two things, so we do want to define sort of another parameter. We could do like P sub D or just P sub 3, honestly. And we'll say, P sub 3 is, and it doesn't matter which way we subtract them, I'm just going to do P2 minus P1, right? So let me actually make that looks like an uppercase P. It shouldn't really be that. So there we go. So there's our parameters defined. We've defined what we're after, which is P sub 3 at the end of the day. And so we want to come up with hypotheses. So a couple things. Here's our null. Here's our alternative. I'm going to do P sub 2 minus P sub 1, and same thing down here, P sub 2 minus P sub 1. We just have to keep track of whether that's going to be a positive or negative number. Now, keep in mind that P sub 2 is the 2005 to 2006, which was a bigger number. P sub 1 is smaller number. So why I'm pointing that out is, first off, for our null, these two things should equal 0. I mean, the difference between them should be nothing. No difference, no change for our null. But we have to decide on whether this is going to be a less than or greater than, or maybe even a not equals to. But there's nothing in this that indicates it's a two-sided test, so I'm not super concerned about that. We did P2 minus P1. So we have a bigger value minus a smaller value. So we're expecting this to come out positive in this case. So we expect this to be a positive number, specifically like 4.5% higher. If we do P1 minus P2, you're just going to do a less than problem instead, because 15 minus 19.5 is a negative number, negative 4.5. So it just doesn't matter. Just keep track of what you're doing. All right, so rules, right? We still have the same rules, our checks. And again, we'll have to do 2 of them just because we have 2 samples, just like we did with the confidence intervals in the last section. We've got the simple random sample, we've got the 10%, we've got the large counts condition again. Of course, we're going to run into a little bit of an issue with this, which we're going to talk about here in this next box. And you can see in this large counts condition that we, at the moment, use P1 or P hat sub 1, P hat sub 2, and things like that. But here's sort of the issue, and this is what this sort of gray box is going to talk about. When we go into a hypotheses test, we always assume the null is true, right? Now that means that P sub 1 equals P sub 2. So apparently, and again, we're not entirely sure what that actual parameter is. That's part of what we're searching for with confidence intervals, and we're proving with significance tests if there's a difference between them, but we go in assuming they're the same. So clearly, since they're the same, they have some value P is a proportion. I mean, it could be like 23 out of 50, whatever our sample size is, and we just don't know what this common value is. I mean, what is P1 and what is P2? Because apparently they're identical, and we have a hard time coming up with this value. And so what's going to happen here is essentially we need to give this a value so that we can do some of our calculations. And that's where this idea of this pooled proportion comes into play. Now, this is more of a vocabulary word that we just need to know. Fortunately for us, our calculator is always going to pool our proportions for us, but we have to come up with some parameter value to run some of these things. And in fact, actually, because of this parameter value, since we're assuming that the null is true, this is going to also be a part of our normality check. It's going to be a part of our standard deviation calculation, and so on and so forth. So what is this pooled value? Well, what we do is we take our samples, right? And what we do is we take the successes from each sample and we add them up, and then we take the sample sizes from each sample and also add them up. And what happens, and I'm going to change a few things on this page, but we get this pooled proportion that we're going to use, and here you go. You can see it down here sort of being used to represent kind of this value that's unknown at the moment between these two things. And it's a nice way to at least estimate, this p-value that we're unsure of. However, also, what we're going to have to get used to is in our large counts condition, we're also going to use that pooled value throughout the large counts condition here. So, we'll change those to p hat sub c, p hat sub c, and p hat sub c all the way through here too. And we'll talk more about that when we get back. But so I guess when it comes to you knowing the pooled proportion, we'll have to get that value and then we'll have to use it in our normality check. So it'll be important for us to look at. Let me just kind of stop there because I feel like I want to talk more about this on Monday in person. And then the other thing too is I want to make sure that we actually kind of see it in a problem so that we understand why that's happening. So I'll leave it at that for now, but we are going to add the successes and then the sample sizes and make one proportion that we can use throughout our problem. Okay, so here's what we're going to do. I am going to stop this here because I feel like I want to come back and I want to do a full problem with you on Monday. So reading quiz 58, I'd like you guys to chip away at that for the rest of the period. If for some reason that video you didn't finish the one yesterday, go definitely finish that too, and we'll go from there. So anyway, I will see you guys Monday. Have a great weekend. Get reading quiz 58 done, and we'll see you then.